Hello dear students, how are you? Hope you all are fine at your home and doing studies well. Students, today I am going to tell you about the properties of HCF and LCM. Now students, you have done already the topics related to HCF and LCM. You have done how to find HCF of two numbers, three numbers, and how to find the LCM of two numbers, three numbers, doing like this. You have done already the all types of methods to find the HCF and the LCM here. Now students, we will do here the properties related to HCF and LCM. We are having some numbers, then how can we find that its HCF is possible, its LCM is possible? This will be the LCM of this number, this will be the HCF of this number, this maybe we will get the HCF of this number. And how do you find the HCF and LCM by another method? Is this clear, students? Now we will do here the property 1. This is the property 1. Property 1 is saying that HCF is not greater than any of the numbers. Never greater than any of the numbers. There are given some numbers here, that is 5 and 15, 3 and 15, 4 and 9, 3 and 9. If you will find the HCF of these numbers, always never greater than these numbers. Never greater than these numbers. Is this clear, students? You are having a number that is the HCF of 5 and 15. You have to find here the HCF of 5 and 15. There is the HCF here 5 and 15. There we will get here the 5. Is this clear, students? So we are saying that this is the maximum number which can be possible here. If HCF is possible, that equals to that number or never greater than the number. Is this clear, students? Now LCM is never less than any of the numbers. LCM is never less than any of the numbers. It may be 5 or greater than 5. Is this clear, students? It may be 5 or greater than 5. But HCF is always 5 or less than 5. Any of the number. Not less than any of the number. That is, it's a smaller number is 5. It means there is a possibility that LCM is less than 5. Not possible. Is this clear, students? Now we have the HCF is factor of LCM. HCF is factor of LCM. HCF is always a factor of LCM. We are having the HCF 5 and LCM of these numbers is 15. And this is always, in any of the question, this is always the factor of this LCM. Always. You will do, when you revise the questions of LCM and HCF, you will see there that this HCF is always the factor of LCM. Is this clear? Now, and again, the next property is LCM is multiple of HCF. LCM is multiple of HCF. It is a multiple of 5. 15 is multiple of 5. 5 3 is 15. It means LCM is multiple of HCF and HCF is factor of LCM. Is this clear, students? Now we will go to the next property, that is property number 5. HCF of two numbers is one of the number, then LCM is the greater number. If you will find that HCF of one number is HCF of two numbers is one of the number. There is a HCF of two numbers is one of the number, that is 5. It means it always be possible that LCM is the greater number. It must be compulsory that LCM is the greater number. So you will find here, that LCM is the 15 here. Yes, it means this is a possible here. Now we will do here the question number 6. HCF of co-prime numbers is always equals to 1, because co-prime numbers are saying that there is no common factor between these two numbers except 1. It means there is only one common factor, that is 1. It means the HCF of co-prime numbers, common factor HCF is the common factor here, highest common factor, and there is only one factor as 1. It means this is the highest. So it's the co-prime HCF of co-prime numbers is always equals to 1. Now HCF of co-prime number is the product of the numbers. LCM of two co-prime numbers is always equals to the product of these two numbers. That is 3 and 5. Let's suppose that there are the two co-prime numbers that are 3 and 5, and we have to find here the LCM of these two numbers. So these two numbers have the LCM as a product of these two numbers, that is 3 5 15. It means their LCM is 15 here. Is it clear, students? Now we will go to the last property, and this is a very important property. It must compulsory to understand this property. Product of HCF and LCM of two numbers is always equal to the product of the numbers. Yes, students, product of HCF and LCM. If we multiply HCF and LCM, it always equals to the product of the given numbers. There is given here, that is 2 and 3 and 5 here. Let's suppose that there is 3 and 5. Its HCF is 1 because these are two co-prime numbers, and its LCM is 3 5 15 here. If we multiply HCF to the LCM, 1 and 15, multiply of 1 and 15 is always equals to the product of these two numbers, given numbers. These two given numbers are 3 and 5. It means product of these two numbers are 3 into 5, that is 15. It means product of the LCM and HCF is always equals to the product of the given two numbers. Is this clear, students? So this is a very important property, and which will be used here in the worksheet, next worksheet, that is worksheet 7. Let's start here. Before starting the worksheet 7, you must need to write these facts in your notebook. Okay, students, let's see there the question worksheet 7 here. Now students, you are seeing here the question number 1, and in the question number 1 we have to verify the product of the numbers is equals to the product of HCF and LCM. We have to verify this problem. So students, there are given here the two numbers. First we have to find their HCF, and then we have to find their LCM. So students, there are the two numbers, that is 10 and 15. First we have to find their HCF. There is the HCF method, long division method, we have known about it. 10 1 is 10, there is the remainder 5. Again it will be divided, it have the division, so this will become as the divided, and 5 remainder is become as the divisor. 5 to the 10 here, and this is 0. There is the HCF as the 5 here. It will done. And now we have to find here the LCM. What is the LCM? We have to find the LCM of 10 and 15. There are the numbers 10 and 15. We have to find the LCM. So it will be divided by 2 first, because that is the 10. 2 5 are 10. 15 is as well because it is not divided by 2. Now we will divide it by 3. That is 5 as well because it is not divided by 3. And 3 5 are 15. Now it will be divided by 5. 5 and 5, 5 and 5. Its LCM is 2 into 3 into 5. 2 into 3 into 5, that is 30. It will get here. Now there is the HCF and there is the LCM. So we have to verify here the product of the numbers is equals to the HCF into LCM. Product of the two numbers is equals to the HCF into LCM. HCF is this, LCM is 30. And this is verified here because both values HCM and LHS and RHS are equal, hence verified here. Is this clear? Now we will find here by same method 35 and 40 are given here. First we have to find here the HCF of these two numbers. There is the number 40. It will be divided by 35. 35 1 ja 35 here. We will get here the 5, and again it will be divided, and this 35 become as the dividend, and this remainder become as the divisor. 5 7 ja 35. It will be the 0 here. Okay, students. Now 5 is the HCF here. So HCF is 5. Now we will solve here the LCM. There is the LCM of 35 and 40. It will be divided by 2. Yes. 35, 2 to the 4, 0. And there is 2, 35, 2 and 2 0, and there is 2, again 2, 35 as well, 2 5 10. Now it will be divided by 5, 5 7 35 and 5 and 5. Now it will be divided by 7 and 7 and 1. There are the factors. LCM is equals to 2 into 2 into 2 into 5 into 7. This will we get here the LCM of these two numbers. 5 to the 10 and 2 to the 4, 4 7 the 28, 280 is the LCM of these two numbers. Now students, we are verifying here. So product of these two numbers 35 into 40 is equals to HCF into LCM. This must be 5 into 280. And what will we get here? 1400, and this must be equals to 1400. It means hence verified. Is this clear, students? I hope so. You will understand these questions, and the remaining questions you will do yourself. In that question, there is a 32 and 48. You have to find the HCF of the numbers and then LCF of the numbers, and then we will check here that this is equals or not equal. Is this clear, students? Now I will go to the next question. Now students, in the question number 2, there is asking that find HCF and LCM by using the property in question number 1. There is a question here, part A. There are the numbers 27 and 90. We have, it is given here again. I am repeating again. Find HCF and LCM by using the property in the question number 1. So students, you are seeing here that so students, it is given here. We have to find the HCF and LCM but by the property. Okay students. So let's see first. We have finding one HCF or LCM from the method as we have done previously. But one after that, the remaining the HCF or LCM we will get from this property. So finding HCF here. 90 divided by 27. 27 3 ja 89. That is 9 here, and this is the 27. 9 3 ja 27. It will get here the LCM. HCF as 9. We will get here. Now we will find here the LCM. So product of numbers is equals to HCF into LCM. We know as well. Now we have to find the LCM here. So product of numbers, this is multiplied here, so it will be there as the division. This is equals to LCM. We have to find here the LCM. So product of numbers is divided by HCF. So product of numbers is 90 into 27, and there is the HCF here 9, that is equals to LCM. 9 1 is 9, 9 1 is 9, and that is equals to 0. So LCM is equals to 70. Is this clear, students? Okay. Now same, we will go to the next question. Now students, if we divide it 145, and there is 87, and it will be divided again. This is 1 ja 87. This is divided again 87, 58. Now again 2 ja 29 2 ja 58. Is this clear, students? So HCF is 29. Now to finding the LCM, we are doing here the same. This will be the same here in all the questions of this part. Is this clear? Now we are doing here the product of two numbers. It means 145 145 into 2382, and it is divided by the HCF. HCF is 29, and 29 5 jar 21, 29 1 jar 29, 29 5 jar 145, and it will be get here the LCM, and this will be multiplied here 1160 as the LCM. We will get here the LCM as 1160. So remaining question you will do yourself. There is one question more. You will try yourself. Okay, students. Now we will do here the next question. Now students, you are having the question number 3 here. In the question number 3, there is given that the two numbers are given here and saying that if these are, can it be possible that this is the HCF or this is the LCM? Any two numbers, for any two numbers, this can be the HCF or this can be the LCM here. So students, you can remind that we are having the properties. In the properties, there is the one property that factor is HCF is factor of LCM. HCF is factor of LCM. If it possible that this is the factor of any number and this is the LCM of any number, it must be compulsory that HCF is the factor of LCM. Or we can say that LCM is the multiple of that factor. We have these two properties there. So we can use here the two properties. Any two numbers can have 16 as HCF and 380 as LCM. Is it possible that 16 as HCF and 380 as the LCM? No, it can't be possible. It cannot be possible. Two numbers cannot have 16 as HCF and 380 as LCM, because if there is a HCF 16, it means this must be the factor of this 380. But it is not possible because this doesn't divide completely the 380. Okay, students? So it is not the factor. 16 is not a factor of 380. And if 380 is LCM there, then it must be the multiple of 16. Is it compulsory? Yes, it is compulsory here. 380 is not a multiple of 16. It means this is the contradictor here. So students, this is the property saying that it cannot possible here the 16 and 380, because 16 is not the factor of this and 380 is not the multiple of 16, because it is not divisible by 380 is not divisible by 16 exactly. Now we will do here the question number 4. In the question number 4, there is given that HCF of two numbers is given here and the product of two numbers is given here. Here is given here question number 4. The HCF of two numbers is 16 and the product of numbers is 3072. So students, you are seeing here that the product of, there is the HCF of two numbers here. HCF is given as 60 and the product of numbers is given as 372. And we have the property that we have to find here the LCM. Then we will do here the product of the numbers divided by HCF. So product of two numbers is 3072 and its HCF is 16. So it will be divided here. 16 into 16, and there is 20, that is 14 here. 16 9 ja 144 and 3 16 2 ja 32. So it will get here LCM as 190. Is this clear, students? Now we will go to the question number 5 here. In the question number 5, there is asking that the LCM and the HCF of two numbers are given respectively. LCM and HCF of two numbers are 180 and 6 respectively. If one of the numbers is 30, find the other number. We have to find the other number here. So students, it is given here that LCM is 180 and HCF is 6. One number is 30 and we have to find the another number. So using this property that product of HCF and LCM is equals to the product of two numbers. And we have to find here the product of this. There is one number, so product divided by HCF and LCM product is divided by one number. Then we will get here the another number. Is this clear? HCF into LCM, we are having 180 into 6. This is LCM here and this is HCF. HCF into LCM. This is 6 into 180 divided by one number, that is 30. 3 1 3, 3 2 6. There is 36 as the another number. Is this clear, students? To find the another number, to find the HCF, to find the LCM, we have all the formulas here. Here is we have to find here the LCM, and here we have the HCF, and here we have the any number. We have to find any number, then we will have the formula this. It's the very important formulas. Remember there. Remember these formulas. These three formulas make clear. Now we have to find here the HCF. In the question number 6, LCM of two numbers. Two numbers are 160 and 352, and LCM is given here 1760. And find here HCF. To find the HCF, product of numbers divided by LCM. Product of two numbers divided by HCF. LCM is finding here. So this is equals to product of two numbers 160 into 352, and it is divided by 1760. 1 0 is 1 0 cut there. 16 1 16, 16 1 16, 16 1 16. 11 1 11, 11 3 33, and 3 2, 11 2 22. It must be equals to 32 as the HCF there. Is it clear, students? This will be the question number 6. Now we will do here the question number 7. It's the last question of this worksheet. Write down these questions. So students, there is the question number 7 here. In the question number 7, there is true and false questions are there. In the first question, there is the part A. LCM of two numbers is a factor of their HCF. LCM of two numbers, LCM is the factor of HCF. No, it means this is the false statement, because LCM is the multiple of any number. We have done already, and we have revised this in the worksheet also. We have the property here. Is this clear, students? Now there is a part B here. In the part B, product of three numbers is equals to the product of their HCF and LCM. Is it possible? No. It is verified only for two numbers, and for three numbers it may or may not be possible. So it's the false statement. Let's see there in the part C. HCF of given numbers is always a factor of their LCM. Yes. HCF is factor of their LCM. It's the right. HCF is factor of LCM. It means this is the true statement. Now we will do here. LCM of given numbers cannot be smaller than the numbers. LCM of the given numbers cannot be smaller. Yes, LCM cannot be smaller than the numbers, and HCF cannot be greater than the given numbers, any of the given numbers. So it's a true statement. Now we will do here the LCM of two co-prime numbers is equal to their product. Yes, HCF of two co-prime numbers is 1, and the LCM of two numbers is LCM of any two numbers is equals to any two co-prime numbers is equals to the product of these two numbers, two co-prime numbers, product of two co-prime numbers. It means this is the true statement here. Is this clear, students? Now in the next class we will do here the value based questions and the brain teachers exercise. So students, do it in the fair notebook, and this is your homework, today's homework. So, and revise your questions also before worksheet BT questions, brain teachers questions of unit 1, and value based questions of unit 1, and worksheet 1 of unit 2 you will revise as a homework, today's homework. Okay students, have a nice day. Bye students.